Can.
Hello, can you hear me?
Yeah, I can
We
hear
can
you.
hear you.
Manuel.
Yeah.
Yeah,
Manuel, can you hear me?
I can hear you. Can you
Okay.
hear me?
Let me start by apologizing for starting this meeting late. We had little challenges, but thank God that we are back. So this meeting is organized by the Society of Petroleum Engineers Abuja Section, and we are happy to host this meeting. We also are happy to have our speaker, Emmanuel Ike, to deliver a lecture that I'm sure that every one of us are interested in. Personally, I'm interested in this topic because we all know what is happening in the world, and these skills are skills that we all need, but we actually need direction because a lot of us want to go into data analytics, but we don't really have the direction. So this lecture promises to be an eye-opener for us and also a direction for each and every one of us. So I will allow the speaker to introduce himself, but there's something I want to say because I know he may not want to say it, so I will just say it. For those of you that don't know, Emmanuel graduated from Federal University of Petroleum Resources in Efru, and back then he was some of you don't know that he's a petroleum engineer because everything that he's doing now is data. He's actually a petroleum engineer. In fact, he graduated with a very, very good grade. And he was part of the footprint team that won the Petro Bowl back to back. In fact, he won it three times. He was part of the team. So you can see that he's one of us. He's an SP member. So without wasting much time, let me hand over to Emmanuel so as he delivers his presentation.
All right. Thank you. Let me share my screen. Can't seem to have the option to share my screen here.
Or should I do that from my end?
Yeah, I think you can give me the permission to share my screen.
Okay.
Okay, yeah. Can you see my screen?
Yes, we can see your screen.
Yes.
Okay. Good afternoon, everyone. Thank you for having me this afternoon. I'm really excited to have the privilege to be giving this talk. This afternoon, I'll be talking to us about the data hierarchy of needs, understanding how the data subdisciplines all fit together. And before I proceed, I hope we're all keeping safe in this pandemic. So before I proceed, just a little bit about myself. My name is Emmanuel Ike, and currently I'm a data engineer at Gamesys. Gamesys is a gaming company in London. I'm passionate about data analytics and using data to gain new insights. For some of you who are not aware, like Mr. Victor has said, I have a very strong affiliation with the oil and gas industry. Having had my bachelor's and master's degree in petroleum engineering, and SP has given so much to me in terms of my career growth and my career development. So it's a privilege for me to be doing this at this point in time. So what are we going to be talking about today, and what is the lesson what is the one thing I want us to take away from this section this afternoon? I know data is, is the buzz of the moment. Everyone is talking about data analytics, data science, and there's a lot of information out there, and it can be quite overwhelming for someone that is starting out their journey into the world of data. What I hope to achieve at the end of this talk, or what I want you to take away at the end of this talk, is to have a solid understanding of the world of data to help you navigate your learning process. And I'll be doing this first by sharing my journey into the world of data analytics. How did I move away from being a petroleum engineer into the world of data analytics, and also talking about the data hierarchy of needs, looking at the data landscape, looking at the different roles and where they fit in. So before going into all of that, let's take a step back and look at where we are coming from so far as a society. Um, we are currently at the fourth industrial revolution for some of us who are not aware. And this fourth industrial revolution is being driven, by intelligence, by data. First, we have the first industrial revolution, which was primarily supported by steam engine, and then we had the second industrial revolution, which was backed up by discovery of electricity, and then in the third industrial revolution we had the computing revolution, computers, smart computers. The fourth industrial revolution is uh, sort of an extension of the third industrial revolution. But what we see is that there's an exponential changes to the way we live, work, and relate to one another. And there's been an increased adoption of technology, especially cyber physical technology systems, Internet of Things, and I'm sure almost every one of us have smartphones these days. So we can all see these things around us and how we interact with this new technology. Now, why the fourth industrial revolution, holds a lot of promises. There's also a lot of socioeconomic dangers that we should be aware of, and that danger being that a lot of industries and individuals will find themselves, in a position where they would struggle. For some certain industries will completely wiped out, or they will struggle. For individuals that do not, upskill or learn new things, they'll find themselves not relevant anymore in this new age that we find ourselves. So with this in mind, one question that come to that one would ask is, how do we proceed? How do I go about leveraging or positioning myself in a position where I'll be able to take advantage of all of these changes that is happening around us? There's this article, this magazine by The Economist on May 2017. And if you look at this picture, it says the world's most valuable resources. I find this particular image very interesting. Uh, Reason being that if you're familiar with the oil and gas industry, you know that you've seen images of offshore platforms. But if you look at the names on them, you see companies like Amazon, Google, Facebook, Tesla, and the likes. There's a lot of meanings that you can extract from this. One, it could be that oil companies are not so big as one as they used to be years ago. Or the other meaning that you can extract from it is that data is the new oil. So that is what is on the lips of everybody. Data is the new oil. So as we proceed into this, we need to understand that the data is very important, and there is a lot of demand for people who possess skills to work with data. If you go onto LinkedIn as we're speaking and you search for data engineer, data scientist, data visualization analyst, you see a lot of roles out there. So what we will be talking about today is how you can, leverage the opportunity that you have to take advantage of the opportunities out there. But before that, there's this quote from Alice in the Wonderland, when Alice was having conversation with the cat, and she was asking for direction, and the cat was asking Alice, "Where do you want to go?" Alice says she doesn't know where she wants to go, and the cat says, "If you don't know where you are going, any road will take you there." It is the same. If you don't have a full picture of the data landscape, you will be overwhelmed with a lot of information that will be coming your way. So with that said, let me take us through my journey. How did I move from being a petroleum engineer to becoming a data engineer that I am currently? Prior to November 2016, as you can see on here, I've never heard anything about data analytics. I didn't know what data science, what it meant. I had arrived London a month earlier in October 2016 for my master's at Imperial College. And there was a lot of buzz around data, big data, data science at the time that it is hard for anyone to ignore. And then one evening, I was coming back from college, and I met this Nigerian who was doing his PhD at Imperial, and then we got talking. And when I asked him what his research was about, he said he was working on machine learning. I was like, machine learning, what is that? So he told me what the research was about and what he was doing. It was something quite interesting. So I went away, did my own research, and I found out that really this world of data is something that is quite interesting. And at that point in time, it looks to be something that is going to have a long-term viability. So right away I started taking courses, looking for courses that I could take. But it was challenging because there wasn't a lot of information out there. People were saying different things. If you ask someone, then what is data science? If you ask 10 people, there's a likelihood that you'll have 10 different meanings. So in that scenario, it was very, very difficult to find good learning materials. Sometimes I'll find myself learning data analysis with Excel. Sometimes I'll be learning Python, sometimes learning Tableau. In some cases, I was even learning technologies that I shouldn't even be learning, all because I just want to learn something. In the end, it took me about a year after I picked up interest in data analytics, and after then I got my first role as a data visualization analyst in my current company. But within that space of me getting, becoming interested and getting my first role, there's a lot that happened behind the scene. A lot of learning, consistency. But something that is very important that I want to point out is the fact that um, having a portfolio is very, very important. In the data analytics industry, companies don't care so much for your certificate. What they care about more is what you are able to deliver. Are you able to demonstrate that you can do this job? And one way that you can demonstrate that is having a portfolio. In July 2017, I started publishing um, Tableau visualizations to my Tableau public profile. And since then, I was trying as much as I could to publish visualizations frequently. That helped me a lot when I went for interview in my first role. They were quite pleased that coming in, I had an experience with this technology already, so they felt like they didn't have a lot of work to do in terms of training me. So that is one thing we should keep in mind when you proceed on your journey to learn. You shouldn't just focus on acquiring certificates, but instead build a portfolio that you can include in your CV when applying for jobs. So since when I got my first role as a data visualization analyst, I have switched roles a couple of times. First from being first from data visualization analyst to business intelligence developer, and then from business intelligence developer to uh, being a data engineer. So all of this is to say that there's a lot that you can do within the world of data analytics. There are different roles, and you need to understand how all these roles fit together. Now that takes me to Maslow's hierarchy of needs. I know you probably be wondering what does Maslow's hierarchy of need has to do with me learning data analytics or me going into the world of data. As I would show you shortly, you will see that borrowing from Maslow's concept and applying it to the world of data, it gives a clear understanding of how the different sub-disciplines relate to each other. Maslow's hierarchy of needs is a motivational theory in psychology that depicts human needs uh, in hierarchical levels within a pyramid. What he was saying basically was that the needs that are at the bottom of the pyramid must be satisfied before you go on to talk about the needs at the top of the pyramid. So, for example, as humans, we would need the basis of life. You know, someone that hasn't had food to eat or doesn't have good water to drink, doesn't have shelter, wouldn't be talking about achieving their full potentials, right? So let's keep this picture in mind and then we move on to data hierarchy of needs. I came across this concept early last year while I was just um, doing my routine surfing of the internet. So this is data hierarchy of needs as illustrated by Monica Rogati. You see, there's a lot of excitement in a lot of excitement regarding data science, data analytics, big data, and what people tend to focus on are things like machine learning, you know, building predictive algorithms to predict things in the future. So they focus on those high-end things and tend to ignore the basics that needs to be in place. And what you find is more often than not, most companies are not ready for artificial intelligence or machine learning. And the reason for that is because they have not yet built the infrastructure to implement the most basic data science algorithms or even machine learning application. Now, for an individual, how important is this to you, or why should this be important to you? The reason why this is important to you is that it gives you a logical mapping or understanding of the data landscape. One of my earliest experience when I started taking courses in data science, data analytics, is that for the courses I was taking, they were always providing CSV files. And I'm sure most of you would have started taking one or two courses already, and you've been provided CSV files, Excel as your data source. That is fine for doing learning, but when you move over to the industry or practicing, what you find is a totally different picture in the sense that nobody's going to hand you a CSV data as a company to work with. You have to generate your own data, prepare this data, transform this data, and prepare it in such a way that it will be in a shape where you can now start leveraging this data to build on more sophisticated algorithms. So if you look at this pyramid, if you see the bottom of the pyramid, we've got, first of all, you need to collect your data. And after collecting this data, you can collect data from multiple sources. It could be from instrumentations, it could be from sensors, it could be from external data, it could be user-generated content. But you need to collect this data. And after you collect this data is in its raw form. You need to transform it, building pipelines to transform this data and moving it to a central storage system where people can access it within your organization. These first two uh, levels in the pyramid at the bottom is usually handled by the data engineers, the data architects, and the data modelers. And then you move up to the higher levels. Once you have your data warehouse in place, then you are now in a position where you can start exploring this data and then aggregating, building data visualizations to look at trends and all whatnot. And then you can, after you've looked at historical trends, you can then say, okay, you want to start building machine learning or artificial intelligence application. So we see here that at the middle level, we've got the data visualization analysts, business intelligence developers, data analysts, and then at the top, we've got the machine learning engineers that build machine learning applications. To sort of bring this home, to make it more relatable, I'm going to be using an e-commerce company as a case study. And we're going to assume that the end goal of this company is to offer personalized marketing to their customers. Now we're going to see how they are going to go about that. How do they extract data and then till they arrive at the point where they are able to offer personalized marketing to their company, to their customers. Now remember, if you look at that pyramid that I showed us earlier, data hierarchy of needs, at the bottom, the first thing we need to do is to collect your data. Now, there are multiple sources of data, depending on your business, depending on your needs, and it depends on what is available to you. Primarily, you can get the data sources could be from sensors, it could be from user-generated data in this case, it could be from external data, it could be from your logs or your application logs. But let's use user-generated data. So if you look at this image, we see a customer that interacts with the e-commerce website and they purchase an item. Every interaction that they have with the website gets stored in a persistent database somewhere behind the scene. Now, to make this clearer, I'm sure some of us will have interacted with e-commerce websites like Jumia, Konga, or maybe Amazon, where you purchase item. It's not necessarily even you purchasing item. The fact that you interact with the website, every interaction that you make is being saved somewhere in the database for them to be able to do their own analytics and do their own build their own machine learning algorithm. And then you've got the warehouse workers that interact with the stock keeping application to make sure that they always have inventories ready to sell to their customers. And then you've got the delivery driver that delivers. You've got a vehicle route planner application that they use to plan their route. All of this gets saved to a database somewhere. Now, all of this data, you have a lot of data on here, but these data, they're not in a form that you can use. The best analogy that I can use to explain this is for those of us in the oil and gas industry. Imagine you go to your reservoir, you drill a well to your reservoir, and you produce oil to the surface. The oil you're producing contains a lot of dirt. You've got water, you've got sediments that needs to be filtered and removed from your that needs to be filtered and removed from the crude oil before you, and what is remaining is now pure, something that you can push to your tanks after they've gone through your separator and the likes. So we can liken this first stage as our crude oil just in the reservoir. Is there, but we can't use it directly because there's a lot of transformation that needs to be done. And that takes us to the next step, building data pipelines. So we have our data in our sales database, our inventory database and our geographic database. How do we use all of this data? How do we extract this data in such a way that the business can begin to leverage this data and gain insights about their operations and make decisions that would impact on the business? Now, this is where the data engineers, the data modelers, and the data architects come into play. The data modelers and the data architects, they are more of the people that design the system. So they consider the location of the data, this case being our data warehouse, and the sources of our data. And based on these two considerations, they would map out a design of how to move data from these multiple sources to our data warehouse location. The transformation that takes place it differs greatly from company to company. It differs based on your need. Transformations could be filtering, it could be removing unwanted columns, it could be filling in missing data, it could be validating data, it could be enriching data with more information. So the kind of transformation that could take place is endless. Again, this is a very simplified view. In reality, what you find is a very complex pipelines. We've got data pipelines that are processes, meaning they run at intervals, maybe daily or every hour or however you want them to run. And we've also got streaming data pipelines where data, as soon as an event takes place on this end, the data is processed immediately and then it goes to the data warehouse. All of that is beyond the scope of what I'm discussing today. I just want us to have that high level overview of what happens. So now once the data modelers and the data architects, they've designed the system, it is now up to the data engineers to actually implement this design, building this whole infrastructure. And from my experience, it's a tough job. Sometimes it can take you a year or a year plus building this infrastructure. Thankfully, there's a lot of cloud uh, providers. You've got of Google Cloud Platform, AWS, Amazon Web Services, and Microsoft as well. So they provide services that sort of makes this whole process of building your infrastructure a little bit easier, but it is still a complicated process. So now we've extracted our data from our multiple sources, we've done all the transformation, and now we have our data in our data warehouse. We are now in a position where we can now start exploring our data, looking at the data to see what sort of insights that we can learn or gain from this data. It might be that as we begin to look at the data, we see that, oh, there is something that we missed, or there's an information that we need that was not added in the initial design of the data pipeline. That is then fed back and then added to the data pipeline. So, but let's assume in this case that we have all our data ready. There's no missing data. We have all we need to begin to start answering the business questions, and then that takes us to the BI and analytics. So now you see I have moved from extracting data, transforming, getting to our data warehouse. Now we're in a place where we can start building visualizations. You want to look at trends. How is my company performing for the past 30 days? How is it performing for the last 3 years? You look at trends. You want to group things based on different levels. You want to do a lot of analysis. So all of this you can do by by building your business intelligence applications using tools like Tableau, Power BI, Excel. I'm sure most of us would have heard about some of these technologies. So this is what we can achieve. when it comes to building analytics application, there are some of the skills that would overlap between data engineering and building analytics application. But in most cases, the set of skills you need are different from the set of skills you need to become a data engineer. And that is the idea that I am trying to communicate with us. For someone that will build an analytics application, they would in most cases be okay by just learning SQL, learning maybe Tableau or Power BI, and just picking up Python, maybe. And that's in case you want to build your own analytics tool using tools like Matplotlib or whatever. So now you're in a position to make analysis. Let's look at this e-commerce company, for example. They want to build a dashboard, so they would end up with something like this, that would give them an historical picture or a big picture of how the business is performing. They can see their quarter to date sales, quarter to date transaction, how many customers bought from us this quarter and things like that. They can look at trends. They can see how sales is performing on a quarterly level. So these are some of the things that you do when you are at that analytical stage. In most cases, the business would have questions they want to answer. Say, for example, the CEO might want to understand how a particular new product that they launched is doing and things like that. You as the data visualization or BI developer, we take their requirements and then go see if you can answer that question based on what you have in your data warehouse. So these are the sort of things that you can do. Now, once you are at this level where you've been able to look at how your business is performing from an historical perspective, you're now in a position where you say, okay, you want to start building um, predictive analytics, or building machine learning or artificial intelligence application. And that brings us to artificial intelligence and machine learning. Again, you see on here that the data that we use for our machine learning comes from our data warehouse. I'm sure some of us that would have done taking exercise from Kaggle or other similar platforms, you are provided a CSV. But in most cases, the data that you feed into your machine learning applications would come from your data warehouse. So in a way, the business intelligence developers, data visualization analysts, data analysts, machine learning engineers are sort of dependent on the data engineers, data modelers, and data architects. This is a very simplistic view of a machine learning application. There is a lot that goes into building machine learning application. In fact, building a machine learning application has got its own different pipelines. So when you're building a machine learning application, let's say you want to build a simple regression model, for example, you want to predict the price of a house given certain features of a house, for example. You pass in all of this record from your database, but you want to do what is called feature engineering, because not every variable in your data would contribute into predicting the outcome you want to predict. So you need to do a feature engineering to select the right variables. And after you do your feature engineering, you train your model. After selecting your model, you train the model. And then after you train the model, you deploy the model to production. And before you deploy, you have to validate the model. And after you validate, you deploy to production. And after a while, you need to retrain this model. All of this is done in automation. Now, that adds a different level of complexity to what we've been talking about. All of this step of the customer interacting with the application, extracting, transforming, loading to database, and then the analytics applications fetch from database and machine learning application fetch from the data warehouse. All of this is in automation, and that is what makes it, really complex. But looking at this, you see that different level of skills, are required based on where you are focusing on. Now, again, if we go back to this e-commerce company, they want to build. Um, I mentioned earlier that they want to build personalized marketing for their customers. Now they are now in a position where they will be able to build that personalized marketing. And one such to do that, one way is to do what they call the recommendation algorithms. I'm sure some of us would have visited sites where you try to purchase an item like this guy here, and then when you buy the item or you're about to pay, they tell you people that bought this item also bought these other items. So all of this is being done by machine learning algorithms that have been built to look at your profile, match it with other people's profile, and see people that you have similar profile with, and then recommend what those people have, that those people have been buying on that site to you. So all of these are things that you can do with machine learning. So there's a lot more you can do, but this is just to give us an idea of what is obtainable or what you can achieve. Now we've looked at how you get data from how you collect your data, how you extract that data from the sources, how you transform this data and then load it to your data warehouse. And then we looked at the analytics application and the machine applications. Let's tie it all together. And this is the big picture that I was talking about. Having this understanding is quite critical. So now you see here that in this area of building the data pipelines, is the people in charge or the people responsible for it are primarily the data engineers, data architects, data modelers. And the skill you require here to become a data engineer, data engineering is sort of a blend of software programming, software engineering, um, business intelligence, and data warehousing. When you go to business analytics application, you need a different set of skills. In this area, in my experience, you most times don't require a lot of programming experience to become a data visualization analyst or a BI developer or data analyst. Basically, all you need is know how to write SQL, know how to use visualization tools like Power BI or Tableau, and a little bit of Python would help. When it comes to machine learning, you would obviously need to understand some basic principles of software engineering. Having mathematical knowledge is key as well. So you see this picture and how all of these different roles and disciplines interact with each other. It sort of gives you a clear picture of how to navigate your learning journey. So say, for example, I've looked at these different roles, different disciplines. I'm interested in learning data visualization. This would help me focus on that because I know where I am going and I won't be distracted with whatever is happening when people are mentioning machine learning or whatever people are mentioning TensorFlow, Keras, or whatever. Or when people are mentioning things like Airflow, people are mentioning things like um, data flow, a lot of technologies related to data engineering. All you just care about is building your skill in this area. Now, again, another thing I want to clarify is I am not saying that any of these sub-disciplines are more important. They are all equally important, even though for you to efficiently do build analytics application and machine learning applications is dependent on the work of the data engineers. That doesn't mean data engineers are more important. Also, it doesn't matter wherever you start your learning from, so long as you're focused in one particular area. I started my journey as a data visualization analyst, and I sort of moved towards data engineering. The journey could be different from for you. You can decide to start wherever you want to start, and then later on transition to a different area. So I hope all of this have been able to give us that high level picture of what the data landscape looks like. And I hope you've also learned something new as you commence your journey. So thanks to everyone for making it to this talk, and I'm grateful for the privilege I've had to give this talk. If there are any questions, feel free to ask. If I most likely know there will be a lot of questions to be asked that we will not be able to cover based on the time we have. If you've got personal questions you want to ask, you can reach out to me on LinkedIn by this link, or just scanning this barcode. So yeah, thank you very much for listening and for attending. Mr. Victor, over to you.
Yeah. Hello.
Yeah, I'm here.
Okay. Yeah, thank you very much, Emmanuel. And I'm sure we've all benefited from this presentation. Emmanuel started from telling us about the fourth industrial revolution, um, which is about intelligence, and we are all familiar with the saying that data is the new oil. And he also went ahead to talk about, he gave us his personal experience, his journey into data analytics, having a petroleum engineering background, and knowing that this is what we need in the future. He had to, go into data analytics. And he also talked about the Maslow's hierarchy of need and the data hierarchy of needs, talking about the bottom of the pyramid, all the basic skills that we need in data analytics and the sought after skills, and he went ahead to the top of the pyramids. He also talked about how the various sub-discipline of data science, he explained the different sub-disciplines, and he talked from data collection to artificial intelligence. Um, I think he was able to cover all this, and Emmanuel, um, I know we actually, it was a very short notice, and you were able to come up with something. Personally, I'm actually, because I'm new to data science, so I believe that this presentation is for me. So thank you on behalf of the SP Abuja session, the chairman, the programs chair, and the YP chair, and every member of SP Abuja session. I want to thank you for honoring our invitation and for this wonderful presentation.
Yeah.
So we'll just go to questions. We already have some questions here.
Okay.
So if you still have questions, you can drop them. So I might mute some persons too. Maybe you can raise up your hand if you have questions, so that I'll just mute you so that you ask your question. So, but we have the first question we have here. I think someone have answered it, but I will still ask you. Okay, let me go with the first two questions. Someone asks, what is a BI? And the
Okay.
other person asks, what is the application of machine learning in the upstream oil and gas industry currently and in the future? So maybe we'll go with these two first, then we can
Okay.
take other questions.
All right. So for the first question that says, what is the meaning of BI? So BI is business intelligence. There's a lot of overlap between what a business intelligence developer does and what a data visualization analyst does. Um, I think the way I see it, business intelligence is more of a legacy role until recent times, where we've got the data science, data visualization analyst. But in most cases, what you find is BI developers, they use older tools. So they use tools like Cognos, they use tools like SQL Server, reporting system, and things like that. But essentially, what they do is similar. And then the second question about application of machine learning in in the oil and gas industry. I haven't actually been following the oil and gas industry closely in the past 3 years, but Then when I was, looking, there was a time where I considered doing a PhD in the oil and gas industry in using machine learning. And there was this professor that I was following then from West Virginia University called Professor Moageg. I don't know if I got the name correctly. He's heavily into machine learning, applying machine learning on on the oil and gas industry. I think there was something he worked on where they were building a reservoir simulation that is not based on analytical solutions, like analytical equations that we know, but using data to sort of build simulation. And also there's been applications in drilling where you can, using sensors, using data that you get from your mud pulse telemetry and all of those jazz, you can use that to predict well problems, before they occur. And also you can also apply that in monitoring your facilities in your production facilities. So there is um, a lot of ways you can apply machine learning in the oil and gas industry. If you really want to find out more, I think the best place to go is One Petro. If you go to One Petro and search for applications of machine learning, I'm sure you see a lot of work that people have done and are still doing.
Okay, thank you very much. I believe that answers your question. So we have another question here. Um, this person is asking, he said, which is more complex to learn as a beginner, data visualization or data engineering?
If I'll be honest with you, I think for a total beginner, someone that doesn't have um, a tech background, starting off with data visualization is easier than delving into data engineering, because data engineering is more or less software engineering, but focused on building data infrastructure. So to become a data engineer, you'd really be good in software engineering, and by that I mean you have a solid understanding of data structures and algorithm. You have, a good understanding of the basic principles in, when writing good software programs. And you need to also understand data warehousing. Now, how do you design a data warehouse? Talking about things like fact tables, dimension tables, and then have some understanding of business intelligence as well. Whereas if you want to go into data visualization, what you need in most cases is learning a tool like Tableau or Power BI, or learning SQL to interact with your database, and also picking up Python, but not at the level of a data engineering. So I would say data engineering is more complex than data visualization for a total beginner to get into.
Thank you very much. We are gradually coming to an end, to end this program. So I still have some questions here. So I'll just quickly take some of these few questions. The first one, let me take two. As a retailing company owner, which aspect is more beneficial? That's the first question. Then the second question, what type of data does the data engineer work with? Structured, semi-structured, or unstructured, or a conglomerate of all?
So for the first question, for a retailing company, what aspect would you want to go into? Um, First, you need to have the basics in place. You need to have your data sources. So for a retailing company, it's more like you are selling goods or items to customers. Some of the questions you would want to know or you want to understand is things like, what are your best selling products, right? And then or you want to know who are your most valuable customers. Things like, you have those sort of questions, and you want to know what products are not making you money so that you can stop selling those products and things like that. To be able to answer those questions, you need to have data. And how do you collect this data? You collect these data when customers, interact with your business, when they purchase items from your business. So at a basic level, what you need to do is to make sure you uh, you take notes of those data, you log those information somewhere. Now, how to collect those data is, I think, is beyond the scope of this conversation. And the other question about what sort of data does a data engineer works with? Um, Data engineers work with all sorts of data, structured, unstructured data. Again, it depends on the question you're trying to work on. So say, for example, like if you will be working with images or videos, those are not structured data. And the way you work with them, the sort of the technologies that you use in working with those set of data is different from when you're working with a relational data, like tables, like customer transactions and things like that. No one data is better than the other. It's more of a case of understanding your business needs. Again, all of the solution you will be building would be dependent on the questions you're trying to answer and your business needs. If you go to a company like Facebook, for example, the data infrastructure will be different from a company like Uber. Does that make sense? So you need to tailor it to your business need.
Okay, thank you very much. We still have we have a few questions here. The first one um, states that what role does SQL play in the big picture? Why another person is asking, he said you should elaborate on the challenges you face while transitioning from the oil and gas space to data science. And
Um,
maybe I can just add one more question. Can I?
Let me take those two first.
Okay,
Let me take
okay.
those two first. So the first question on what role does SQL play? I think SQL is very, very, very important skill to have. Um, Almost everything you'll be doing, you would almost be interacting with a database somewhere. So you need to know how to query data, how to join data from multiple tables, how to union data from multiple tables, how to perform analysis using SQL. So having SQL is knowledge of SQL is indispensable in your learning, in your journey into the world of data analytics. And the second question on what challenges I faced while transitioning. Um, I think for me, I didn't have so much of a challenge in the sense that I was in a place where um, we've got good internet connection, um, access to resources wasn't a challenge. I know that for most people, that would be a challenge for them, not having access to resources or not even having what they need to be able to learn in the first place. So that is one challenge. Also, for people, I know for most of us, it's not like we're just sitting and not doing anything. So some of us got jobs that we are doing at the moment. Some of us are studying. Now, how would you be able to create time to learn this new skill when you're doing something else? It's another question on its own. For me, it was very difficult at the time because I was doing my master's at Imperial College, and if you ask anyone, who has gone through the petroleum engineering program at Imperial College, they would agree that it is a very, very tough program. I was having classes Monday to Fridays, 9 to 5 p.m. in the evening. And then on top of that, I was still able to squeeze in at least 1 hour every day to take those courses. So that is one set of challenge. Um, the other set of challenge I faced was, when I started applying for roles, I had a lot of rejections. I sort of lost count of how many roles I applied for. I think I probably would have applied for upwards of 200 roles. I can't even recall. But one thing is, once you go through the process, don't take the rejections personal. Just see it as part of the process, because once you learn from the process, once you go for an interview and they ask you a certain question and you're not able to answer, or you failed, you messed up in the interview, you will learn not to make that mistake in the next interview that you go. So it's just a way of, you just need to keep at the back of your mind that you won't get a job in your first application. Rejections will come, but you just need to continue. So I think these are some of the challenges that that come to my mind at the moment.
Okay. Thank you very much, Emmanuel. I think this will be the last set of questions that we take. But before then, please, for those of you that needs, don't know, Emmanuel,
Yeah.
your slides, a lot of persons are interested in having your slides. Hope you don't mind.
Sure, sure. You can send them
Okay, so please, instruction to getting the slide is on the chat room. So just kindly check and you see how to get the slide. And also, before I take the last set of questions, I want to inform us that tomorrow we'll be having another lecture. This time is going to be practical, and it's about beginning with Python programming for your everyday life. So whatever you're doing currently, if you are working, you may need Python to make your work easier. So please, we want you to join us tomorrow by 3 p.m. to for that section. So let me take the last set of questions. This first person said you should elaborate on who designed the transaction system on slide 17. Why the other person is saying, he said there are a lot of courses online. Some persons will say you can finish data science in 30 days, some in 100 hours. So he's asking, how will you know the right course to take, as in based on the content of the course? So what will you advise? What are the sites? What's your advice on the kind of course and the people that will deliver the best course?
Okay.
This data science.
Okay. Yeah. So to the first question, the transaction system. So I left this on purpose because if you look, this is more about building websites, and this transaction system is more for the software engineers and web developers that build application. So they build this application, and to accompany the application, the application has got its own database. So it isn't for the data engineers to give it. So which is why I didn't talk more on that. To the second question about can you remind me second question again?
On the sites, there are some persons who say 30 days. It's asking about the content, the course content
Okay, yeah.
for various instructors that you advise them to take.
First of all, you cannot learn any of the data skills in 30 days. It's a lifelong journey. I've been at it for 3 years now, and I'm still learning. Um, Although I've come a long way, there's still a lot I still need to learn. So it's a continuous process. And the mindset you need to have when you come into the world of data is you won't stop learning. There will always be something new that comes up every day that you want to learn or that you should learn. Otherwise, you just become redundant. So in terms of content, I think it is up to you as an individual. Once you know what you're looking for, um, the way I approach it is, say I want to go into data visualization, for example, I go on LinkedIn, look at the job openings out there, look at the common skills that most of those job openings are looking for. Now, if I find about 3 or 5 of the most common skills that they are looking for, that will sort of give me an idea of the things I need to learn to be able to impress at my interviews. So that would inform the courses that I should be taking. So now, when you go to a particular course and they don't touch on these core skills that employers are requesting for, then it's an easy decision. You shouldn't be wasting your time learning something that wouldn't help you in the long run, because I'm sure for most of us, we're not learning data skills because we just want to learn them. We're learning them because we want to get a job. And I think that should be the way we approach evaluating courses to take.
Okay. Thank you very much, Emmanuel. I think we've been able to answer all the questions.
Yeah, thanks. It's a great privilege to be able to give back to SP. You know, SP played a huge role in my career growth. So anytime I'll be glad to come back and do this. And you can find me at LinkedIn if you've got more questions to ask regarding resources or any other question. Just feel free to reach out to me on LinkedIn.
Okay, thank you very much, Emmanuel. Thank you everyone for joining us. We're glad to have you in this session. So we're hoping that we're going to see you tomorrow in our next session. Emmanuel, please, I think I made you the host. I don't know if you could.
Oh, okay. Let
Okay.
me stop sharing and. What is your name here?
SPA Abuja.
Okay. You want okay, yeah.
Okay. So thank you everybody, and also want to also thank the SPA Abuja session again.
Thank you, Victor.
Okay.
Thank you.
Okay. And everybody, thank you for coming. So hope to see you tomorrow.
All right. Thank you.
Okay, bye.
Winston.
Baba. Salute.
Winston.
Thank you very much.
Glad to have you.
Same here, Baba. All right. Tomorrow then.